Hello, algebra students, and welcome to lesson 6.3 on exponential growth and decay. Last lesson we talked about exponential functions. Today we're going to talk about growth and we're going to talk about exponential decay. All right. So a very short set of notes, just 3 slides up to this one. So let's get going. So example 1, it says exponential growth, right? So the population of Hillville grows at an annual rate of 15%. What will be the estimated population of Hillville be in 5 years? So we can model exponential growth with this function, and this is just our exponential function from last lesson. Now, the one stipulation is that this b value, that constant ratio, right, that base with the exponent, that has to be a number bigger than 1. This will ensure that your model is growing. Now, for an exponential growth function, we are going to, instead of using b, we're going to use this thing called a growth factor. And this growth factor is going to be 1 plus the growth rate. Now, your growth rate will be a percentage. You must change it into a decimal. So again, this growth rate is going to be given to you as a percentage. You must change it into a decimal. But here is the function right here that you need to remember for exponential growth. A times 1 plus r to the x. So again, that b value is just being replaced with 1 plus r. Okay. All right. So let's look at the problem itself and try to solve it. So it says that we're growing. So now we know we're exponential growth, right? So we need to use this formula. The rate that we're growing at is 15%. So that is your rate. However, we need to make that a decimal. So if it's a double-digit percent, then the rate as a decimal is just 0.15, right? 0.15, right? The official thing is you either divide by 100 or you move the decimal 2 places to the right, and that's going to go in front of the 0.15. Okay. Now over here in the sign, they give us the current population. The population of Hillville is 5,000. This is our initial value. So if you recall from our 6.2 notes, the initial value is the a in the equation. That's an a, not very clear a, but it's an a. Make it bigger, a. Okay, about the same. And it says what will be the estimated population in 5 years. So time is typically our x value. Sometimes you use a t, but in here we're using an x. Your time, your x, is 5. So we have everything we need. We have our rate, we have our time, our x value, and our initial amount. So now we're going to take our formula. I'm going to do this in blue here. I'm going to bring it over here. So f of x equals a, our initial amount is 5,000. Don't use parentheses, or don't use a comma. Plus, our times 1 plus your rate is 0.15 raised to the, and we're raising it to the 5th power. And here we go. So now we're going to go, however you want to do it. I like to simplify that first. So this is 5,000 times 1.15 to the 5th power. And again, this just ensures that my b value is greater than 1 and it will grow. So you'll just type this into Desmos exactly as it looks. And I'm going to round to the nearest whole number. When you do this, you get 10,057. I'll put a comma in the final answer. And that would be the population of Hillville in 5 years. So if you don't plug in the 5 for x, right, this formula, this growth function is f of x equals 5,000 times 1.15 to the x. It's just the same as last lesson, right? It's the exact same thing. All right, but now we're going to be plugging in some x values and finding some outputs. Okay, let's do the next problem here. Okay, so it says exponential decay. A video is labeled a fan favorite if it receives at least 1,000 views per day. Amelia posts a video that gets 8,192 views on the first day. The number of views decreases by 25% each day after that. And how many days will the total video stop being a fan favorite. So now you can see that there's this word decreases in the problem. So now we're doing something called decaying. So let's talk about our exponential decay model. So when we're decaying, it's the same formula, but now your b value is between 0 and 1. It's like 1/3, 1/2. You're multiplying by a number less than 1, so you're getting smaller. So now the decay factor is going to be 1 minus that decay rate. So now here is the formula you must remember. F of x equals a times 1 minus r to the x. So again, they're replacing this b value with 1 minus r. And it should be a number less than 1 because you're subtracting a number from 1. Okay? All right, so let's take a look at this problem here. So again, in the first day, it gets 8,192 reviews. That's also here in the table. That's going to be your initial value. That's the initial value. So again, that's going to be your A in the formula. It says it's decreasing by 25%. There's your rate of decay. Move it 2 places to the left. It's 0.25. Right? And now the question really asks, in how many days will it stop being a fan favorite? For it to stop being a fan favorite, you must not get the 1,000 views per day. So this views is actually a Y value. They're saying, when is the Y going to drop below 1,000? So we're going to need to use Desmos to do that in a little bit. But for right now, let's build the model. So I'm going to make the model here in orange. So f of x equals, okay, so our initial amount A is 8,192, parentheses 1 minus 0.25 raised to the x. I'm going to simplify that, so f of x equals 8,192 times 0.75 raised to the x. And this is my model. So now what I'm going to do is I'm going to graph this and this. And I'm going to estimate the x value, the number of days, when I have less than 1,000. So let's do that. I'm going to have you sketch a small little picture on your notes as well, but we'll do that when we get there. Okay? All right, so let's clear that. Let's open up Desmos here. All right, so I'm going to zoom out 1. So here we go. So I'm going to type in f of x equals 8,192, parentheses 0.75 raised to, and again, you can use the caret button, or you can come down here and use this, right? Raised to the ABX. Okay. Now notice that my graph is not showing because I need to be in scale. So again, 8,000 is the highest number of views. So I'm going to use the wrench. I'm not going to zoom out, right? Because if you zoom out, you're zooming both out, and you'll eventually see it, but it's not a good picture. I mean, that's not a good picture, right? So I'm going to use my wrench. I'm going to change my x scale. Now, my x is like the number of days. So I'm going to go from like 0 to, I don't know, 0 to 20. 0 to 20. And then for the y, I'm going to go from 10,000 to 0, sorry, from 0 to 10,000. 0 to 10. I was thinking decay. Okay, there. And there's a good picture, right? So that's what it looks like. So on your paper, if you would for me, right, would you please sketch that? Just have 8,000 up here, right? And just have it go just like so, right? And make sure this is marked as around 8,000, right? That's the initial value of 8,192. And now in the next box, I'm going to type in y equals 1,000, and it's going to put this horizontal line here. So on your graph, if you want to put 1,000 and draw this horizontal line, but we're looking for that point right there. The x value is going to be our number of days, and the y value will be 1,000. We're looking for the first day where we drop below 1,000. Okay, so let me type that in right here. So y equals 1,000. Okay, and as promised, there we go. And this point is roughly 7.3 1,000. So I'm going to make this a 7.3. So that means after 7.3 days, there's going to be 1,000 viewers. So if we keep going, 8, 9, 10, 11, we're going to keep dropping because we are decaying. we're going towards the x-axis. We're going towards 0 viewers. So we can't have 7.3 days, so we have to round up to the next day. So instead of 7.3, we're going to say after 8 days, we would no longer be a fan favorite. Okay, I got one more. So I'm not going to stretch it to a second video, so let's just power through on this video. We got one more problem to do. All right, let's get it going. All right, next one. It says exponential growth and decay. Rich is comparing the cost of maintaining his car with depreciating value of the car. When will the cost and value be the same? So when you see these words the same, right, we just did a whole topic 4 over systems. This is about a system of equations and where those two systems cross. Now, you're going to see that we have this word decreases and we have this word increases. So what's going to happen here, and let me just do it graphically real fast, is we're going to have a decreasing, a decaying model, something like this. And we're going to have a growth model, something like this. And what we're trying to do is we're trying to see when will the costs and the value of the car be the same. We're looking for that point of intersection xy. So again, we will use Desmos. That's why I have the button here, okay, to do our graphing for us. But I want to create the two functions by ourselves. So I'm going to do the decreases one in red because that decreases means bad. So it starts with $20,000. That's your initial value. So first off, let's write the original problem. So f of x equals a times 1 minus r to the x. Okay, so f of x equals, so our initial value a is 20,000, no commas, times 1 minus your percentage is 0.15 as a decimal raised to the x. And if I subtract 1 and 0.5, I get 0.85. So f of x equals 2,000 times 0.85 to the x. And we'll graph that, right? Okay, and now let's do the increasing one, and let's do it in green. So now we have f of x equals, so now our minus sign turns into a plus sign, a times 1 plus r to the x. Our initial value here is 500, so that's the cost of maintenance. So typically, when you buy a new car, your maintenance cost starts low, and then it grows as your car gets older. Our percent is 0.28 as a decimal, so 1 plus 0.28, and that's to the x. I should not be using f of x, I'm sorry, let's call it g of x. Again, we should not have two f of x's. So g of x equals 500. 1 plus 0.28 is 1.28, and that's to the x. And now it is these two functions that I will type into Desmos, look for that point where they intersect, and answer the question, what will the cost be, when will the cost and value be the same? Okay, so let's get ourselves to Desmos. I'm going to press the home button. I'm going to clear these. I'm going to zoom out 1, and now let's type it in. So my f of x, this is my decay function, equals 20,000 times 0.85 raised to the x. And again, it's going to start at 20,000, so we will definitely change our scale. Our growth, g of x, g for growth, right, is going to be 500 times 1.28 raised to the x. And again, you can see it here, but its initial value is 500. So I want to say, I'm going to change the x. X is the number of years, so let's go to 20, right? Maybe you have a car for 20 years. And now on my y-axis, I'm going to go up to 25,000, just so that I have the 20,000 within my scale. So I'm going to change my x's to 0 to, I said 20. And my y's, I'm going to change from 0 to 25,000. No commas. 25,000. Good. And as promised, right, I told you, there's that picture. And we're looking for the point where they intersect, and that point is right there, 9.01 and 4.624. So I will say, as an estimation, I will say in about, I wish that point would stay. So 9, 4, I'm going to say 4,600. So in about 9 years, the cost and value will both be about $4,600. In about 9 years, the cost and value will both be about $4,600. Big section here. The state test loves growth and decay, so it's very important you understand 1 minus r for decay, 1 plus r for growth. Okay? And it all goes back to the f of x equals a, b to the x exponential function formula. All right, sorry for the little bit longer video, but hey, there's only one, so I think we could do it. All right, thanks for watching. See you in class.